Hi guys, in this session I would like to demonstrate how to build a classification model using decision tree for the data set iris. So I think you guys know what is iris data sets. So it's a flower data. There are three types of flowers: setosa, versicolor, and virginica. So based on the features like sepal length, sepal width, petal width, you can determine the type of flower. So there are totally 150 rows and 5 columns. So these are the 5 columns. Our target variable is like a class label. So you can determine the type of label based on the other four features. So let us see how to build a classification model by using decision tree. So I hope you guys have the basic knowledge of decision tree. So decision tree is a tree like structure in which a root node has all the attributes, and then the nodes are split into sub nodes, and finally the tree is constructed. Once the tree is constructed, you can have the target variable at the end, at the terminal node. So I'm going to import these libraries, importing caret and also importing this rpart.plot for plotting the decision tree. So once these libraries are imported, we can go for importing the data set. So this iris is a predefined data set, so we are just loading iris is equals to data set, then specifying the data set iris, then displaying the header part of the data. So when you do that, you can see this is the header. Head means by default 6 rows in R programming, and you can see the data dictionary here. The data frame is created with the name iris. 150 observations means 150 rows, and 5 variables means 5 columns. And if you click on this iris, then you can also see the data, actual data. So the target variable is spaces over here. So based on the sepal length, sepal width, petal width, you can determine the type of flower. So first 50 rows, first 50 samples belongs to the class setosa, next 50 versicolor, and next 50 virginica. So totally 150. So let us see how to create a decision tree for this. So once the data frame is created, I'm checking dim of iris means what is the dimension. Dimension means the number of rows and number of columns. So we have 150 rows and 5 columns. Then having a table of the target variables. So iris dollar spaces means you are accessing the spaces column, then having a table. So we have 3 unique values as I mentioned: setosa, versicolor, virginica. So 50 plus 50 plus 50, totally 150 samples. And you can have a descriptive statistics of this data set. So this is the descriptive statistics. So the number of columns are mentioned, and in each column the metrics like what is the minimum value, first quartile, median, mean, and third quartile, and maximum. It means this is 25 percentile, median 55 percentile, third quartile means 75 percentile, and the maximum value. So that is the descriptive statistics, and then we can check the data types. So we can call the str method, str of iris, which will give the important information like what are the columns, and then what are the data types. So you can see these are all the numeric. So 4 columns which are all numeric, and then we are setting some seed value here, 3033. You can set any value to access the rows in random. And then this create data partition is available in the library that we have imported, caret. So we can create or we can partition data into the parts like training and testing. So in train is equals to using the method create data partition, and target variable is spaces from iris data frame. Partition value is 0.7 means 70% training, and remaining 30% is going to be testing. List is false means we don't want to list the partition values. And then splitting this into 2 parts, training, testing. So training is equals to iris of in train. So getting in train value 70%, and minus in train means other than 70% is assigned to testing. So after that we are displaying the dimensions of these, right? Displaying the dimensions. So train dimension is 105, of 5. So 105 rows, 5 columns, and the dimension of testing, which is 30%. So 45 rows, 45, 5 columns. So this is data partition. And then we are also using crash validation here. Repeated CV. The method is repeated CV. The number of folds are 10. Means your data set is split into 10 folds, 10 partitions, and repeating 3 times. You are repeating this for 3 times, and also setting the seed value. Then you are building a decision tree here. So df tree info is equals to decision tree, and this is equation. The spaces is depending on tilde operator dollar, means depending on all the columns of the data frame. And then data used is training. So the model always learn from trained data, and the method is R part, means decision tree, and the parameters list is equals to this is parameter tuning here. Splitting is based on the information gain. Training control is TR control, means tenfold cross validation, and the length of the tuning is 10. So with this the tree is built. And then PRP, so we are just having a table of we are having the decision tree created and also displayed with the I missed this. Let me just run this completely. The decision tree model is built. Then so displaying the tree here, PRP of this is a model. Okay, the name of the model dollar final model, and back palette is reds, means you can have the color filled with the red color. So this is the root target, the node at the top. So if the petal length is less than or equals to 2.6, if the petal length is less than 2.6, then you will just traverse this path. Then the target variable is setosa. Else if it is no, then again you test if the petal length is less than 4.8. If S, then the target class is versicolor. If no, then it is virginica. So decision tree is constructed. So once the tree is constructed, you can evaluate your model. So test prediction info is equals to making the prediction. This is your model name, and then new data is testing. So for 30% of the testing data is used, and then having a confusion matrix between actual and what the model has predicted. So when you do that, the prediction is done, and you can see the classification report here. So in Setosa class we have 15 samples, 0 misclassified into versicolor and virginica. In versicolor 13 are correctly classified, and 1 sample misclassified into virginica. Similarly in virginica 2 are misclassified into versicolor, and 14 samples are correctly classified. And the overall accuracy is 93.33. right, this is 93.33. You can also see the other metrics here. So this is the statistics of the data. And then next we can also build another model, right? We can also build another model based on the Gini coefficients. So setting the random seed here, and then the model name is decision tree fit Gini. So everything is same, but there is only the change of the split value, that is Gini. Earlier we have used information gain, now Gini index, tenfold class validation, and then again plotting a tree. Okay, plotting a tree. Now the tree is constructed. You can see this is the tree. If petal length less than 2.6, S setosa. No, you check petal length less than 4.8, then versicolor, otherwise virginica. So this tree is similar with the previous one. Now let's evaluate this model. So making the prediction for test data by using the model, and then having a confusion matrix. So here you can see the same as I mentioned. The output is almost same. There is no difference here. 15 samples correctly classified into setosa, 13 are correctly classified into versicolor, 1 is misclassified into virginica, and then in virginica 2 are misclassified into versicolor, 14 are correctly classified, and the overall accuracy is 93.33. So we got the same accuracy when you compared with the previous model. So this is how the now tree is constructed, how the decision tree is constructed using R programming. You can also take any other data set, but the process is similar here. So you can just load the data. Once the data is loaded, you can check for missing values. You can do pre-processing. Once the pre-processing is done, you can split the data into training and testing, then build a model by using training, then evaluate your model by using test, and then finally display the results. So you have to show the evaluation by using some metrics. So this is the general process of building a decision tree in R. So you can also take some other data set and follow the same process to build a classification model. So this is a classification problem because our target variable is string type. If it is a numeric, then regression. So decision tree can also be used for regression analysis. It is used for both the purpose, classification and regression. So for more queries, if you have, you can just reach out to us, and do comment and like our videos, and subscribe our channel so that you'll be getting the updated videos. So thanks for watching.